and put this unit to review. Okay, so this is our assignment we had to get through. It has half the questions that are on the assessment, the actual assessment. So let's look at number one. Number one has, we got f of x is equal to 3x minus 5. So I won't be able to like slow down to wait for you to copy this stuff down because I want to get through as many as possible. So just do your best, and you may have to watch the video to get the rest of the notes, okay? So we have this function, we have a domain we're given. Now, it's important that we know that our domain are just, our x values, okay? As opposed to the range, which is what we're trying to find. We're trying to find the range, which are our y values, okay? So the y values we're going to fill in as we plug in 2, as we plug in 4, 6, and so on. So looking at that, what we have to do is we're going to take f of 2. You see, I take the first term in the x, I plug it in, 3 times 2 minus 5, 6 minus 5, 1. So I plug in 2 and I get 1. All right. So when I look at this, I really want to keep in mind that domain is just the x values. Range is just the y values. And if I asked you all one at a time to, can you plug in 2 for me for x? Can you plug in 4? Can you plug in 6? Everyone would be able to do that because we've done quite a bit of it. So this is something you already know. And now we're going to go ahead and plug in one more. Let's see if it'll give us the answer. F of 4. 3 times 4 minus 5. 12 minus 5. F of 4 is 7. Okay, 7. And looking at our answers, yeah, this we already know is going to be answer D because we have the first two terms of the y values. In order to match it with the options they give us, this was D. But I'll go ahead and do the last one too, f of 6 in fast forward mode. 6 minus 5, 18 minus 5, 13. Okay, so what we've just done is plug in an x, get your y. Okay, so this was D. Actually, you know what? I'm going to leave those out. I'm just going to go over the problems. Ha 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 ha. All right, I'm giving you a lot. To support you doing well in this test. The district assessment as well, that is the boost. So the district assessment is the boost. There's no retakes for this, but I'm giving you the district assessment to automatically get 5 extra points on it, which is about a grade boost. Okay, so that's what you need to get completed with that. Okay, now let's look at number 2, and I'm just gonna do my best to draw number 2 because it is a graph. And when I look at number 2, they give us this graph. So for number 2, we're looking at, let's see, that's up at 3, and it's going down to 2. And they want to know f of 2, 6, 4, 5, 6. Okay. So what they give us for this is, given the graph of f of x, this is f of x, what is f of 2? So we don't have a function. We have nothing to plug in. But when we're given just a graph, all we have to do is go to the graph. You guys might remember these, some of the Kahoot problems we did with this. All we have to do is go to the graph and see, well, what is going on when x is equal to 2? What does y equal? That's what it's asking. It's saying when x is equal to 2, what is y, the y value? So what we're going to do is look at 1, 2, and let's go up and see, well, what floor are we on if we take elevator 2? So when we take elevator 2, we're up here at 6. So that was easy because this point here is 2, 6. That's what I needed to find. F of 2 reminds us what we plug in for x. We plugged in x is 2. We get a corresponding value of 6. Okay, so those are pretty quick. Those are going to be really quick. Those kind of problems. You know, if you're making a graph, just to write this down, it doesn't have to be perfect. You can express the method in finding your y value by just copying it down kind of shorthand. So let's go ahead and do that. And then I'll look at number 3 and get ready one other thing we need for number 3. All right, so keep copying that one down. And the next thing we got to do, oh, I have it here. That's right. The next thing we got to do is remember our geometric sequences, our geometric sequences and arithmetic sequences. Okay. Wow. Okay. So remember, we have these two things for number 3. Okay. Now, with number 3, we're asked for number 3, we're told this. We're told that a sub n is equal to a n minus 1 plus 4. A sub 5 is 12. We need to know what a sub 7 is. Okay. So first off, I want to look, and they don't tell us if it's geo or arithmetic. Is it arithmetic or is it geo? So what we need to do is we need to look at our two formulas here, and it really looks like it is in a recursive form, because if I look here, my recursive form for an arithmetic formula is just the next term is the prior term plus d. Because it has plus 4, that is a good indicator that we're talking about an arithmetic. Okay, so you'll have your notes available. You'll look for all the formulas. Nope, it definitely doesn't look like this. It doesn't look like that. It doesn't look like this explicit formula up here. It really looks like this recursive formula. Okay, so what we know from this is, let's see, a sub n minus 1 plus 4 plus d. So I know it's arithmetic. I know that my d value is 4. So this gives us enough information to figure out our way through this. We don't even have to create an explicit formula from this. What we can do is we can note what we're given. We're given that a sub 5 is 12. So, dot, 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 a sub 5. We're going to look at a sub 6. And what we're looking for is a sub 7. So if a sub 5 is 12, and my d value is plus 4. My d value is plus 4. We add 4, we get 16. Oh yeah, I remember this. We add 4, we get 20. And that's what we were looking for. We were looking for a sub 7 is equal to 20. Okay? So you're going to be given a type of equation that is one of our geo or arithmetic. You have to figure out if it's arithmetic. I did that by comparing it to my formulas. This plus 4 is a good reminder. And now I know it's arithmetic. Now I know that the d value, our common difference, is plus 4. So given that we had a sub 5, I put that in there, plus 4, added 4 to get 16, added 4 again, and got my a sub 7. My 7th term is 20. Ah, okay. All right. Yeah, no worries for coming in late. We're doing the entire time. We're devoting the entire time on the review worksheet. Okay. And this is recorded. I'm doing this for all my classes, so I'm trying to do them one after the other and making my way through them pretty quick. Okay. So I'll just move up number 3, make it so you can still see it. Yeah. There we go. All right. Now let's look at number 4. All right. Number 4 has this question. What's the rate of change? The rate of change for f of x is equal to 5 times 2 to the x over 4 over interval 8, 12. This isn't a point. This isn't like a point with, parentheses, right? This isn't a point like that. No. This is an interval. And an interval is looking at x values, our lower limit and our upper limit. Okay. The lower and the upper values here. If I need to know the rate of change, I need to know the slope. Okay. So I want to right off the bat throw in my slope formula here, because I know I'm going to use it later. I got to do another step first. y2, y1, x2, x1. Okay. Now, what I know already is that my lower x value that I'm interested in, this is like the cropping problem, where we crop the picture. We had the lower limit is 8, the upper limit is 12. So it doesn't really matter what this function looks like. We just know that we're looking for the point on the function where x is 8 and where the x is 12. That's going to give us 2 different points. Okay. So essentially what we're doing is this. We're breaking up the interval to have one value that's 8, one value that's 12 for x, right? The reason being is that is the boundary for the slope that we're going to look for. So we're looking for the slope between 2 points. Then we'll put it in our slope formula here and find it right away. So the thing we have to do is first finish up the points here. Once I know my 2 points from my lower and my upper limit for x's, then I could plug it in and find my slope. So look, we got x is equal to 8. Watch what I'm going to do. Take my function. F of 8 is equal to 5 times 2 to the 8 divided by 4. Okay. And then what we're going to do is, this is 5 times 2. 8 divided by 4 is 2. Right? So I'm just working my way through it, finding the y value so I can plug it into the slope. And then we have 5 times 4. We got 20. So when I plug in 8 for x, I get what for y? 20 for y. Now over here, we have to do f of 12. 5 times 2 to the 12 divided by 4 is going to be 5 times 2 to the third. It's going to be 5 times 2 to the third is 2 times 2 times 2. 8. So we get 40. F of 12 is 40. 40. You see? All I did was use what they gave me, the interval. I knew that was the lower and the upper x value I need to look at. I found my 2 points, and now all I need to do is go back to these points and say, well, this is going to be x sub 1, y sub 1. This one over here is going to be x sub 2, y sub 2. Okay? x1, y1, x2, y2. And then all we have to do is remember, oh yeah, why did we put this here again? Why did we put this slope formula over here again? Because, showing you what we did again, we're given an interval for a function. The lower x value and the upper x value for the points. We found the y values that correspond with 8 and correspond with 12. Now we have 2 points, essentially the 2 points we want to look at to find the slope between them. Okay. So now I'm going to plug in, let's see, I'll plug in 40, I'll plug in 20, I'll plug in 12, I'll plug in 8. Just make sure it's y2, y1, x2, x1. It doesn't matter which points, x1, y1, x2, y2. It doesn't matter which point you choose. You just got to be consistent. Okay. So let's see. Now we have 40 minus 20 is 20. 12 minus 8 is 4. So we got our slope for this is positive 5. Done. All right. You might be screenshotting as you go through this if you want to get the notes and not have to watch the video again. So go ahead and get screenshotted with that. But the main thing for these type of problems, if they ask for the rate of change is slope. Make sure you note that so that you have that. If they ask rate of change, you know it's slope. Let's see. We're given the function and the interval, which are x values, lower and upper limit. We plugged the point to complete here. X is 8. X is 12, finding the y value that corresponds. Then we have the 2 points to find the slope between. We found the slope using the slope formula, and voila, we have it. Ooh, okay. We're doing pretty good. We got 10 minutes, and I say we keep on moving, don't stop. All right, let's see. Let's go to number 5. Ooh, number 5. Number 5 is a fun graphing one. Okay, let's do it down here. All right, so I'm going to ask you to screenshot number 4 because I need to move along. It's screenshot in 3, 2, 1. Screenshot. What? Oh, yeah. Don't put too much weight into what letter is being called with the answers. Sometimes test makers will be like, yeah, I'm going to give them 10 C's in a row. The answer will be C 10 times in a row because people will be like, did I mess up? Go with your first instinct, guys. Trust what I've taught you. I believe in you guys. You guys have been really doing well with all this. So just remember, trust yourself. Trust yourself. All right. Here are our two, for number 5, our two functions, inequalities that we need to graph. Okay, we got to graph these guys. Now, when I look at this, first off, it's not in my y equals mx plus b form. That's going to be helpful because we have to graph. That's going to be graph this, right? Step 2 is going to be, is it solid or is it dashed? Step 3 is going to be shade above or below. Okay. So let's change this. Let's change this so that it's in a slope-intercept form. I'm going to move this. Well, actually, it's going to take a second. All right, let's do this one first. 3x minus 4y is less than or equal to 16. I need to move my x over. Minus 3x minus 3x. Negative 4y is less than or equal to negative 3x plus 16. That moves the 3x over from the left side. We want y by itself, so this is where I need to go in and divide by negative 4 everywhere. Because I divided by a negative 4, I got to switch the direction of the inequality. The negative switch is key. If you don't know the negative switch, then the one other problem that's going to be similar to this, you might miss it. Okay, so make sure that you reference this process. You divide by a negative with an inequality, you got to change the direction. So I do that. Over here, we end up with 3/4 x. Here, we're going to end up with negative 4. All right. So all right. Hey guys, let me know in the chat if you came in after I started doing the review, because I ought to do roll. I'd rather just have a line in the chat. So if you're marked absent but you don't tell me, okay, thank you for letting me know. In the chat, let me know if you came in late. All right, it's just going to me. Thanks. That's going to help me do roll at the end after. I don't want to waste time on it. Okay. So look, I converted all this. I got my new form of the equation, so I put it over here. You see, I'm just converting these guys so that they're in the y equals mx plus b form, so I'll be able to graph them easier. Okay. Now let's do this one. Let's do the next one. Okay. So for this next one, I have 4x plus 3y is less than 9. Let's go ahead and subtract the 4x to get it over there. Bye. 3y is less than negative 4x plus 9. Now, I just subtracted the 4x, so I do not have to change the direction of the inequality. It's only when you multiply or divide by a negative. Okay? So I'm here. I need to get y by itself, divide by 3, divide by 3, divide by 3. See ya. Y is less than negative 4/3 x plus 3. Okay, I did it. And now we have our two equations we can reference to graph and do this problem. Now it's going to go quick because now I have this. Now I have my equations in my slope-intercept form. So that's great news. That's great news. Now when I look at this, now I'm going to do my steps. And I'm going to get ready to graph this. All right. Okay, let's graph the first one, the green one. We're going to graph the y equals mx plus b. That's what we have. Then we'll deal with the inequality information. Negative 4 is my b value, and here's my slope. In this one, 3 is the b value. Here's my slope. So let's do the first one, negative 4. Boom, negative 4. We're going to go up 3 over 4. Up 3, right? And to the right 4, because they're both positive. So I go up 3, I go over 4, I end up here. And I know this is going to be my line right here between these 2 points. Now, is this going to be solid or dashed? What I look to is this. Oh, it could be equal to. It's greater than or equal to. So this is going to be a solid line. Then I look to see, do I shade above or below? I just have to look in this first part right here. I have to look right here. Because this is saying that y values are greater than, the y values greater than this line are above it. They're above it. So I'm just going to put some arrows above. Okay. Now this next one, let's graph it in green or red. I'll do this one in red. So look, for this, plus 3 is my y-intercept, up 3. Up here at y is equal to 3. What is it? It's negative 4 rise. That's going down 4 and to the right, positive 3. Down 4 and to the right, positive 3. Down 4 to the right, positive 3. Here's my point. I just counted it. Count down 4, count to the right 3. All right. Now, when I look at this now, is it going to be dashed or solid? There's no equal option here. It's just less than. So because it's just less than, our solutions have to be off of the line. So we're going to make a dashed line. That's kind of dashed. Okay. And then where do I look to know where I shade? I look here. Y is less than. Y is less than. So what is less than for y values? Down. Less than. Less. Down. Okay. So I look at this now. I'm done. I just need to shade it. Final shade. It's below the red. Below the red. It's below the red, so these parts up here are out. All right, below the red. It's below the red. It's above the blue. Above the blue, below the red. I hope we're getting better at knowing where to shade. We've done quite a few of these, at least a dozen over our study of it. So we have that area shaded. And that concludes number 5. This is number 5. All right. Let me see what's next, and if we'll have 3 minutes, if 3 minutes is enough for it. All right. If you just walked in and you're in this class, send me a chat right now to let me know you're in this class. You came in late, because I can't stop to do roll right now. Okay. 6 is going to take too long. 7 will. 8 will. 13 probably will too. I don't want to start it with 2 minutes left here. So I expected this. Yeah, you can stay. I expected this because very few had done the assignment. Like in all my classes, I have like 6 people have done the assignment. So I am going to continue to record these problems, start to finish through my classes. So at the end of the day, you'll have to check the video if you want to look at a particular problem, okay? That's the best way I can do it. That's the best way to organize this so that the video is helpful later, okay? So you can fast forward around because you'll know they're in numerical order. All right. Guys, let me know, or I'll pause this first. Pause. It's going to be kind of all the different topics meshed together anyway. Okay, so this is why I'm doing it, just so it's in order. Number 6 says we're given the equation for f of x is right here. F of x. Looks like we're going to have to compare these two functions. And the table that represents g of x, right? So we have x, we have g of x. And the table has negative 4, negative 29, negative 2, negative 17, 2, 7, 4, 19. Okay. So what we have to do is which of the following statements is true about the functions g of x and f of x? And what they're asking, or what they're saying is, they're basically asking questions about the y-intercept. The y-intercept is our initial value. So this is one of those problems. Really, we're just comparing. We're comparing f of x and g of x in terms of y-intercept. That's the main thing we're trying to accomplish. We're comparing these two things in terms of our y-intercept. So with our y-intercept, let's see, in the chat, somebody tell me for f of x, what is our y-intercept? That should be pretty quick. What's our y-intercept? Yeah, good. The y-intercept is just going to be, if this is y equals mx plus b, the y-intercept is our b value. So this has a y-intercept of -3. All right, that was easy. I love it when they give it to us in that form because we didn't have to do much work for that one. But for the other one over here, yeah, we're going to have to do some work. And the main thing is we want to keep in mind that we can use our slope-intercept form of the line and the points given in order to find this equation, and then it'll be just as easy as with f of x. We can find what the b value is really quick. So we're going to put all this into a slope-intercept form, and that's going to help us out. Okay. So the things we need for that is, first we need to have our slope, and we're going to have to plug in some values for x and y to find what's left over, b. Okay. So this is where, for this problem here, I need to find the slope first. y2, y1, x2, x1. Okay, this had a little faster pace than a lesson. This is like me just going over the problem. Okay, so I'll give you moments to screenshot, but this video will be in sequence, so it's easy to skip ahead and just look at the problem again. All right, so I need to find my slope so that I can plug it in and then plug in one of my points, x, y, to have b left over. So that's what I'm doing here. I'm trying to figure out, okay, what is my m? And eventually I'll find what my b is. All right, I'm finding my slope first. Let's use these 2 points because they're both positive. And I'm thinking that might help us. x1, y1, x2, y2. So I'm going to put in 19 minus 7. I'm going to put in 4 minus 2. Hey, this might actually go pretty quick because we got all positives. 19 minus 7 is 12. 4 minus 2 is 2. So we get a slope of 6. Okay, but that's not what we're comparing. I need to find what my b value is, what my y-intercept is to compare between these two functions. These are two different functions we're given. So now when I look at this, I'm going to put in what I know. I just figured out that I know my m value is 6. And I don't know b yet. That's what I'm looking for. So what I'm going to do is I could pick any of these points. Any of these points because it's part of function g of x. I could plug in for x and y and it'll still balance. It'll still work. Okay. So keeping that in mind, what I'm going to do is keeping that in mind, what I'm going to do is I'm going to pick this point. I'm going to pick this point just because they seem like easiest numbers to work with. You can pick whatever point you want. And now I plug in 7 for y, 2 for x, right? These 2 points, x and y, x here 2, y 7, those came from the point up here that I was given. So I know it's going to work. I know that this will work out because I'm using the points within the function that I was given. Now, let's go ahead and work it out. 12 plus b minus 12 minus 12. b is -5. I just found that my slope is 6. My b is -5. So b is -5. That's my y-intercept. So now I just need to look and compare these. And if I was looking at this, I would say, let's see, function f of x has a greater y-intercept than function than g of x, sorry. And that's one of the answers. Function f has a greater y-intercept than g of x. Here's why. If I have a number line, here's -3, here's -4. So I know that -3 is greater because any value going to the right, any value to the right of another number is greater. -4, -3. here is f of x, here's g of x. So that's where I'm saying, as far as y-intercept goes, f of x has a greater y-intercept than g of x. All right, cool. All right, guys, this is one of those moments I'll ask you to screenshot number 6 in 3, a 2, a 1. Screenshot. All right. And let's see, what do we have in time here? We're doing pretty good. All right, we're doing pretty good. All right, this next one, this is number 7. Number 7. And this one we're getting into our explicit and our recursive formulas. This is what number 7 says. It says, I'm just going to write it this way. What is the explicit function represented in the table? 1, 2, 3, 4. That's nice. -5, -35, -245, -17, 15. This is where we are going to put a third column, and this is where we're going to either have a common ratio or a common difference, or a ratio of change, or a well, we can call it common difference. So when I look at that, yeah, it's all rate of change. Yeah, ratio of change or rate of change. Okay, so it's going to be a ratio of change if it's geo. It's going to be a rate of change if it's arithmetic. So first we have to figure out, first step, is it arithmetic or geo? Okay, is it arithmetic or geo? So when I look at that, I want to look and see, how do you go from -5 to -37 to -254 to 1,715? Now I look at that and I could tell right away, I'm not just adding, subtracting a number to get to the next number. That's too big of a gap. It's too big of a jump. What I'm doing is I'm multiplying by some number. So I know I'm looking for my ratio of change. I know it's geo. I know it's geo, because how do you go from -5 to -35? You'd have to subtract 30, but if I subtract 30, I don't get to 245 negative. I must be multiplying by something to get up in my terms here. My x values are in order. Yes. So what I need to do to find the difference, the ratio of change, I need to look here at, we're going to do the next divided by the prior. We're going to do the next divided by the prior. Next divided by the prior. Whoops. Okay. So that's how I set up my ratio of change. The ratio is always just the next divided by the prior. Okay, you're going to do that to find how much of a change it is. Now, when I look here, I know this one's 7. And I do a little mental math. Yeah, that's going to be 7. That's going to be 7. So I know my ratio of change, 7. Okay. Now, this is where we have to think about, okay, I know it's a, we're looking for an explicit formula. So this is where I come back to my arithmetic versus geo formulas. And I'm looking for the explicit formula. We already figured out it was geometric because we're multiplying the numbers to get to the next term. So I need to copy this one down. Okay. So let's see. Let's put it down here. So I'm taking the explicit formula from the geometric sequence. And I'm just going to have to plug in what I know and what I don't know, and find what I'll know at the end. Okay. So here's our explicit formula, right? Explicit formula for geosequences. And now just focusing on it and what we know here. Do we know the first term? Tell me in the chat, what's the first term? Yeah. Yep. Very good. So the very first term is -5. So what I'm going to do here is I'm going to just plug that in there as I go through this. -5. Now, what was my rate? What was my rate? One sec here. Oh, I see. Yeah, 7. We found the rate here. We used the third column to find the rate in -1. That's all we had to do, guys. We just had to find the explicit formula for a geo. Okay. All right. Let me double check that. So go ahead and take a screenshot of that. I'll take any brief questions on that if anyone has them. Anyone have some questions? Oh, good. Everyone's here. Good, good. All right. All right. Now that's number 7. Number 8. Yeah, number 8's a good one to do. All right, moving on. Screenshot in 3, 2, 1. Screenshot. Okay. So just remember every time that when you're looking for an explicit function or a recursive function, you're going to have to find 2 parts of it. We don't ever plug in for n because an explicit function allows us to find any term. So now that I have this, I could plug in 71 for n and find the 71st term. All right. Let's keep going. We have 15 minutes left. Let's see what we can get through. All right, guys, here's what we have for number 8. If f of x is equal to 5 to the x, g of x is equal to 6, what is f times g of x? Okay. Now, remember that all this is saying is this is f of x times g of x. That's all that's saying. F times g of x. This is f times g, right? F times g. So f times g of x is multiplying the 2 functions together. So all I need to do here is go in and I'm going to put f of x. I'm going to put 6, and I'm going to think about this. Because, first of all, PEMDAS tells us to do what? PEMDAS tells us to first look in the parentheses. I look in the parentheses. There's nothing I can simplify. 5 to the x. X is a variable, so I can't apply it. I can't take the exponent and apply it to the base of 5 here. 6 is 6. So PEMDAS, parentheses are done. Now we look to the exponent. Can I apply the exponent? And this is where if you get stuck, then you're done. Okay. So we look here. Can I apply the exponent? It's 5 to the x. I can't apply x as an exponent to my base of 5. I can't do it, so I got stuck. So guess what? Dang it. F of g of x is equal to, I'm just going to put them in the order that is more typical to an exponential function. That is all we can do. You get stuck, you're done. Okay, so remember, PEMDAS only works if we can do the step prior. Now, it doesn't mean that when we looked at parentheses, we didn't get stuck on parentheses because there was nothing to do in the parentheses. There's nothing more we can do or simplify, no terms to combine or anything. Then when I go to the exponent, it's specifically asking if I can apply the exponent. I cannot apply it because it's a variable, so I'm stuck and I'm done. So I just rearranged them so that it's more of like a times b to the x kind of explicit formula or exponential formula there. So that's all we had to do for number 8. That's it, guys. That's it. Let's see. I want to have about 3 minutes left in class. So, okay. We're going to look at number 13, which is a little more complicated. Let me see if I can change this up. No, I'll just write it out. I'll just write it. Okay. So problem 13 and 14 have a scenario to it. Let's see. Read each scenario, then write a function and graph it to solve the problem. Okay, no problem. So I'll just give you the bullet points for number 13. Your starting balance, money in your pocket, $575. Each month, you deposit $60. Write a function, model the scenario. Okay, so first off, if I'm depositing money, am I going to be adding to the balance or subtracting from the balance? Am I adding or subtracting from the balance? If I'm depositing money, if you deposit money, what is happening to your balance? You're getting more money. If you deposit, all right. Okay, maybe we need to know this. Maybe you didn't know this. All right, here's your bank account. A deposit is when you add money to it. A withdrawal is when you subtract money away from it. Okay. So depositing is adding money. So because I know I'm depositing this $60, I know I'm adding $60 each month. Okay. So if I'm making an equation, remember that we have a rate of change, right? Rate of change. And we have our initial amount, initial value. So all we have to do for 13, this is 13a. For 13a, all we have to do is plug in our rate of change, 60, and our initial value, 575. And that is our equation based on how many months. Because look at it, if I plug in 1 for x, that's 1 month, I'll have $60 extra added to my amount. If I plug in 2 for x, that's 2 months, it would be 120 to my amount, my original amount. You see, so 10 months, I'll have $600 added to it. Okay, so this is all we had to do for A. Now B is create a graph to show how much money Adam has in his savings account for each month of for the first year. Okay, so hey, for B we just got to graph it. Okay, so I'm just going to make a real basic graph. I'm going to say they want to know through 12 months, so I'll put 12, I'll put 6. And let's go ahead and graph this. I'm going to put, let's see, I'll make this 500. I'll make this 750. I'll make this 1,000. It's not to scale. And I'll make this 1250. So look, I'm starting with 575, so I'm going to put it right here. I add 60 every month. So let's see. So every month I'm adding $60. So if I think about it, after 1 month I have, I have 635 $635. So it's not even that far up here. It's going to be like that. It's going to be like that, like that, like that, like that. And let's see, if I do 12, if you did it perfectly on a graph, you would just be able to look at the graph and find it. But I didn't do it perfect, so I'm going to double check what I got. Plus 5 equals 1295. All right, so I did pretty good, actually. Okay, so that's our linear equation. It's supposed to be perfectly straight. And what I find is at 12 months, I'm at 1,295. Because I would, if it was like, done on Desmos, you would be able to see and focus in and find where 12 is. Maybe I'll make this question a take home you could use Desmos for. All right, that is B. We had to graph it. Found our equation, we graphed it. Now C, identify the key feature of the function. Determine the x and y intercepts, the maximum, the minimum, whether the function is increasing, decreasing rate of change of the function. No, we're not doing that. Not included. You don't have to do it. Wait, does that mean we don't do the homework? No, don't do. All right. Okay. All right, we got 6 more minutes. Let's see about this. Decrease the population. Ooh. Not included. No, don't do. Not on the test. As said, we're going over problems. Half of these are going to be on the test. So if I said don't even worry about it. You don't have to worry about it, man. All right. Good double check. Sorry for my slight attitude with that. All right. So we have 5 minutes left. I don't know. We could try. Let's try to do number 14. All right, 14. Population of bees is decreasing. Bees, pop, decreasing. The population in a particular region this year. So the population is 1,250. After 1 year, the population will be 1,000. After 3 years, it's going to be 640. We got to write a function for this. So what I'm going to do is this. Look, we got after 0 years, it's 1,250. After 1 year, it's 1,000. After 2, we don't know. After 3, it's 640. All right. So this is where we're going to create an exponential function. This is going to be the ratio of change. Why? Well, let's see. This is where you can kind of test it. You could say, well, it would be minus 2,500. It would be minus 250 to go from 0 to 1. So let's see if that works if I just keep subtracting it. Minus 250, minus 250. Now, this would have to be 500 if it was just subtracting a number. So we know it's a ratio of change. We're multiplying by some value. That means we're trying to fill in this equation. Our initial amount times the rate to the x value. So you know what? I already know the initial amount. The initial amount is 1,250. If I find my ratio of change, I plug it in here and I'm done. That would be it for A. That sounds pretty easy. So when I'm looking at that, I'm going to go ahead and figure out the ratio of change by taking the next and dividing by the prior. I don't have information here, but I'm going to assume that from 0 to 1 is the correct rate, and it's going to continue. So if I take 1,000 and divide it by 1,250, I get 0.8. Now let's see if this works. Because if I multiply 1,000 by 0.8, I'll get this value. Then if I multiply by another 0.8, I should get this value. Remember, because it's multiplying the same amounts as we go down. So we had multiply by 0.8. I think it's going to be multiplied by 0.8 again. And this should give us multiply by 0.8. So let's do 1,000 times 0.8. We get 800. Let's do 800 times 0.8. We get 640. So yes, I found my rate is 0.8. Ooh, that rhymed. My rate is 0.8. I'm late for an important date. Check it. 0.8. We got A. You see how quick those are? Remember, we like exponentials with this type of problem. We like exponentials. Okay. Create a graph. I'll let you know. B is not included. Okay. I'm not going to make you graph exponentials. That wasn't a standard. So no, don't do. Okay. Number 3, identify the key features. C, not going to do it either. No, not included. No, don't do. Okay. So that's all I really wanted you to do for 14. For A, all you had to do is find the equation. We did that over here. Okay. So we've gotten through 14. The other video I'm going to show, there's 3 more questions, and that will be it for this review. So it's going to be about an hour-long video, but they're in order, so you can skip ahead. All right, I'm going to pause it. In the document, there's a 2, 5, and 6. Those are going to be our B values. Okay. So look, number 2 is saying this. We're trying to figure out, we're comparing. Let's see. We're comparing the y-intercept for f of x and g of x. All right. I'll give you a time to screenshot all these as we go through them as well. Okay. So don't worry if you can't keep up. That's why the video is being recorded for you to fast forward through. Look, they gave us an equation for the first one. I really like that because we're going to be able to find the y-intercept really fast. In fact, somebody tell me what the y-intercept is for that as I copy down g of x. Yeah, if you know it, tell me. So these are very similar to what we saw in the Kahoot as well. Good. Everybody's like, I know this. The y-intercept for f of x is just our b value, and it's plus 8. That's our y-intercept. Okay. So we don't have to do much for f of x. We got our answer quick. Good, good. Now, looking at this, I want to get this into mx plus b form, so I can do the same thing. If I use the table to figure out what the equation is, then I can go in and I can just plug all that stuff in, find my b value real quick. Okay. So here's what we have to do. We have to find what the slope is, and then we're going to use one of our points in order to figure out that whole equation. All right, welcome to class, Renee. Renee, get out a piece of paper. We're going right at it. We're on 2B. Wait a minute. Wait a minute.